Hi everyone, this is another IGCSE Paper 4 question that one of you sent me this evening and apparently was really struggling with. So I thought I'd spend a bit of time here to really reassure you and show you how this question should be answered. Now we're told here, first of all, I should say, I'm given an XY grid, and as I'm sitting in the exam room, I pick up on the fact that the x-axis goes from -3 to 3 and that the y-axis goes from -6 to 6. Now, since this is a paper 4 question, we're allowed to use the calculator, and really what you should be making a note of there is the x and y values that they're giving us, because those will be your window settings on your graphical calculator. Okay, I'll get back to that in a minute though. Now we need to sketch the graph of y equals to f of x, where f of x equals to x squared minus 4 inside an absolute value for x values between -3 and 3. Okay, well, to sketch that, really, the thing to do is to go ahead and dive onto our calculators and plot it. Okay, now on the screen here, you can see that I'm on my calculator's scratch pad, my TI Inspire CX. And so in the upper left-hand corner of the screen, I can toggle between the calculator and the graph, okay? So I'll go ahead and go into the graph, and I now need to enter this equation. Now, there are several ways of entering the absolute value function. The way I do it is I just type ABS for absolute value. And as I do so, by the way, notice that the letters go from being slanted to straight. That means that the calculator has detected a function, and put simply, that means that you're dealing with the absolute value function here. I then open up a pair of parentheses and I type x squared, so x raised to the power of 2, minus 4. Done. I exit that pair of parentheses and I click on enter. Okay, I've now entered the function, and in fact, the label always bothers me. I'll just delete that. There we go. I've now got my curve, plotted, and I'll go ahead and adjust the window settings. And don't forget to do that, by the way. So for this calculator, I click on Menu, followed by the, fourth option, Window/Zoom. Sorry, that got a bit scruffy. There we go. Fourth option, Window Zoom, and the first option, Window Settings. And this is where I'm going to type in the x values I see on the x-axis and the y values I see on the y-axis, meaning my x minimum is -3, so I type that, -3. My x max is 3, so I type that as well, 3. My y minimum is -6, so of course I type that. And my y max, well, that's 6, so I type that as well. Done. I'm happy with all that, and I click on OK. All right, now what we see on the screen here is what the examiners expect us to be working with, okay? So don't go adjusting that. Now, to sketch that, really, although they don't ask, you want to do this properly, okay? The examiner will pick up on a few things, and whether or not they ask, and whether or not it's part of the question further down, you'll see what I mean in a minute, you should always do this before sketching the curve. You want to find any values of x at which the curve either crosses or touches the x-axis, and here you can see there are 2, right? So let's find those first. I do that by using the 0 function. So to do that, I click on Menu, followed by the 6th option, Analyze Graph, followed by the first option, 0. I'll start with this one over here. Lower bound it's asking me for, so I go to the left of that point. Anywhere to the left will do, and I click. It now asks me for an upper bound, so I hover over to the right. Done. I have that first 0. It's at -2, 0. Okay, I'll do the same for the second one. Click on Menu, followed by Analyze Graph, followed by 0. So the second one is over here, so I go to the left of it, I click. It's now asking me for the upper bound, so I hover over to the right, and I click. And this 0 is 2, 0, okay? You're probably already noticing this curve is completely symmetrical, okay? And I'm sure you can see it's symmetrical across the y-axis, and I think we're actually going to be asked that in the next question. Last but not least, though, we should really pick up on where this curve crosses the y-axis. Now, as I'm sure many of you know, to find where it cuts the y-axis, that's the y-intercept, and that's the point at which x equals to 0. So to find that value of y, well, technically I could just replace x by 0 inside the function f of x, and in fact, I'll tell you what, I'll scribble that on the side. One way to find the y-intercept would be to, just let x equal to 0. That's always the case, right? And so if I do that, then y would be equal to 0 squared minus 4 inside an absolute value. That's equal to, 0 minus 4, so that's negative 4. So y would be equal to the absolute value of negative 4, which is just 4. Okay? Now, I'm sure you can do that. That's not a problem. But in case, you get the exam jitters and you're in the exam room and you just want to be absolutely, certain, to find the y-intercept here, I go ahead and click on Menu. I then click on Table, okay? And I only have one real option here, Split Screen Table, so I click on that. Now remember that the first column here, this one that I'm in, this corresponds to the various x values. The second column are the output values, so the values of x. So what we want to figure out here, sorry, the output values, I just said the values of x, I meant the values of y, okay? So let me say that again. The first column are your x values, your second column are your y values, okay? So the y-intercept happens when x equals to 0, that's the cell I'm in right now, and the corresponding y value is 4, which is what I got by replacing x by 0, of course, inside my function, okay? There we go. So that was just to confirm that you could find it with your calculator as well. Now I'm going to get rid of that table. So I click on Menu, Table, and I'll just click on Remove Table. There we go. Okay. At this stage, I have all the information I need, really. And so I'm quite comfortable in sketching this graph. And to do that, let's see. I start at negative 3. And actually, I'll tell you what I could do. I could be really rigorous here. Let's come up with a method to make sure they cannot not award you full marks. I'm going to figure out how high up this curve goes at x equals to negative 3 and at x equals to 3. Okay, it should be the same y-coordinate at negative 3 and at 3 since this curve is symmetrical. But let me just take this opportunity to show you something, how I can quickly calculate the value of f and therefore the y-coordinate at both x equals to negative 3 and at x equals to 3. So on my scratch pad here on the upper left-hand corner, I hover back to the calculator part. Because I've now plotted that curve, remember its name was f1 of x, that function is now stored in my calculator's memory. And to evaluate that function at any value of x, so in this case we'll start at x equals to negative 3, to evaluate the function there, I click on the var button directly above 9. I click on var, and that's my function, f1. I click on that, and to evaluate it at negative 3, I type negative 3. Done. I click on enter. So I now know that I have to start at a height of 5. Of course, as I said, I could confirm that I should get the same value when x equals to 3. And so I click on var, f1, and I click on 3, and enter, and that's 5 again. Okay, great. So we're now in a good position here. If I go back to, and in fact, I'll tell you what, I'll make a note of this on the side here. Just imagine that up here. This is sort of like my scratch pad, more, my notes that I'll cross out before the end of the exam. So f1 of negative 3 is equal to 5, and f1 of 3 equals to 5 as well. Great. Okay, I'll go back to the curve. So with all that in mind, I'll go ahead and draw something looking vaguely like this. I'll start here. I'll say that's, roughly 5. I sketch the curve going downwards like so. I'll now label this. That's at negative 2 on the x-axis. And I want to make sure that it joins roughly the same point on the other side. I then draw a curve shooting upwards, like so. Remember, it crosses the y-axis at 4. And last but not least, I want to make sure that it's roughly the mirror image here across the y-axis, and so I draw something looking like that. There we go. You could go as far as labeling the endpoints here and saying that's negative 3, 5, and that's 3, 5. Okay? Of course, it touches the x-axis when x equals to 2 there. There we go. Okay, now, if you do that, they cannot not award you all of the points there. That's 3 marks for sure, okay? And as I've often said in class and elsewhere, whether or not you're asked to do that, to sketch the curve, you should always do that. You should always find where it crosses the x-axis, okay? You should always find where it crosses the y-axis. Those are the points that the examiner has to hold on to give you points and to check whether or not you've done it correctly. Furthermore, at the IGCSE exam and other exams, the following questions often require you to find these values anyway. And I'm sure we're going to see that in just a second. So, firstly though, question B, we need to write down the equation of the line of symmetry of the graph. Okay, well, as we've already mentioned, it's quite clear that the y-axis is an axis of symmetry. And the y-axis, remember, consists of all the points in the xy plane whose x-coordinate is 0. The y-axis has an equation, and it is x equals to 0. And so that's the answer here. Oops, sorry. That's the answer we're meant to be writing here. X equals to 0. Done. Next thing we need to do is write down the zeros of f of x. Okay, well, that's what we did to sketch our graph properly, right? Here are the zeros where it touches the x-axis. So we have -2 and 2. And so in this case, we could just state, okay, well, that's -2 and 2. Done. Okay, so the zeros, remember, that means the values of x at which f of x equals to 0. Okay, and I'm sure based on how long that was, that's why we came up with the term zeros. Okay, next thing we need to do, we're told find the value of k when y equals to k meets the curve y equals to the absolute value of x squared minus 4, so that's the curve we have here, 3 times. Okay, all right, well, let's see. Y equals to k, okay, well, that's just a horizontal line. Remember, if I remind you on the side here, and I'll do that in green, if I have an xy grid, really quickly, x and y, okay, any equation like this, y equals to 3, will just be a horizontal line whose height is 3. Okay, so that would be y equals to 3, and it would cross the y-axis at 3. Another example, of course, could be, let's say, about this one here. That could be y equals to -1. Okay, that would be, and it would cross the y-axis at -1. That's the, and of course, here's the origin. Okay, so the point I'm making here is that y equals to k is a horizontal line. And so what they're actually asking us here is, okay, where can I draw a horizontal line on this graph such that it meets the curve, the one we just drew, 3 times? And I mean, after just a bit of inspection, in fact, you know, I can quickly do that, and I'll erase the lines as I go. You know, if I were to draw a line here, for instance, well, it only cuts the curve twice, right? At this point and at this point. On the other hand, if I were to draw a line somewhere here, well, you know, that line cuts the curve 4 times. Indeed, 1, 2, 3, and 4. If I were to draw a line, I should say, along the x-axis, well, that only touches the curve twice at the zeros, right? On the other hand, I'm sure you can already see it, if I draw a horizontal line which passes through that y-axis, sorry, that's not very horizontal. I think you get the idea, though. Let me try and do a better job than that. There we go. If I draw this horizontal line, well, this one, hey, that one definitely touches the curve exactly 3 times. And just as I reminded you of a minute ago, you know, the equation of the line each time is, well, you know, y equals to 3, consists of all the points on the line whose y-coordinate is 3. And consequently, it cuts the y-axis at 3. Well, this horizontal line here cuts the y-axis at 4. So that's got to be the line y equals to 4. Okay, that's the answer here. So we're looking for y equals to k, which meets this curve 3 times. Well, we've just shown it. K has to be 4. And that's the answer. We can go ahead and state that k has to be equal to 4. Okay, nearly done. The second part to this question, and I cropped the picture a bit, but this was worth 2 points. We're asked to find the range of values of k when y equals to k meets the curve that we have, the y equals to absolute value of x squared minus 4 times. Okay, well, I mean, just by inspection, we'd already started to look into that, hadn't we? Just a few minutes ago, I drew that and then erased it, but let's see. We had seen that if I draw a line here, it cuts the curve 4 times, right? 1, 2, 3, 4. And in fact, that will be true if I draw a horizontal line here or underneath that green line as well. But we've just seen that when y equals to 4, the line only touches the curve 3 times. We had also seen that if we draw a horizontal line along the x-axis, then it only touches the curve 2 times, remember, at the zeros. And so, in summary, provided the horizontal line we draw is between 0 and 4, not included, then the horizontal line will cut the curve 4 times. And that's the range of values you need, the one I just stated. All the values between 0 and 4, 0 up to 4, not included. okay? So here we have it. I'll just write that down here. K has to be less than 4, okay? So it's got to be underneath the purple line I drew here, okay? But it's got to be above the x-axis, so above 0. Above y equals to 0, right? So, but it's got to be greater than 0. That's the range of values. There we go. That's how we answered this paper 4 question, everyone. I hope that helped.